Hello, differential equation students. So now we'll take a look at some basic definitions and introductions to differential equations. So what is a differential equation? To know that, let's take a look at what do you mean by an equation, what do you mean by an expression, and what's the difference between an expression and an equation. And then let's take a look at some examples of an equation. So what's an equation? An equation is basically you have an expression that has an equal symbol. So for example, you can say x is equal to 1. That's an equation. You can also say 1 plus 1 is equal to 2. That's another equation. Or you can say a plus b is equal to 5. So the idea here is, or you can say, for example, chicken is equal to, I'm just making it up, right? X squared, right? That's an equation there. So basically, you have a left-hand side and you have a right-hand side, and you have an equal symbol in between, right? That's the equation. And here you have a left-hand side and you have a right-hand side, and then you have an equation right there. And that's how we call something as an equation. So what's an expression? The expression is basically anything, right? Any algebraic expression or any numerical expression, any trigonometric expression. It does not have to have it does not have to have an equal symbol. It does not have to have an inequality symbol. It does not have to have any equality or nothing whatsoever. So, for example, um, if you take a look at this one, a plus b the whole squared, which is a squared plus b squared plus 2ab. This is an equation, by the way. It's also an expression, and that expression is a plus b whole cubed. That's an expression. X plus 5 is an expression. So anything like this is an expression. In this case, these are algebraic expressions. So what is the difference between the expression and an equation and the equation? The difference between the expression and the equation is the equation has an equal symbol. Expression may not have to have equal symbol there. Expression, I mean, equation is also an expression, by the way, but not all the expressions are equations. Let's take a look at some examples of an equation. So what are the examples of some equations? I think we looked at some earlier. EC is equal to, E is equal to, EC is equal to, say, E is equal to MC squared. That's an equation. X squared plus 5 x plus 4 is equal to 0 is an equation. X cubed plus 5x is equal to negative 3 is an equation. So you can keep on go there. And there are many types of equations. These are algebraic equations. You know that there are numerical equations, there are trigonometric equations, and so on. So there are exponential equations, logarithmic equations, and then you can keep on go forever. So for example, this would be sine squared x plus cosine squared x is equal to 1 is an trigonometric equation. And e to the x is equal to 5 is an exponential equation. And if you want to take a look at log x is equal to 1 is a logarithmic equation. So these are some examples of an equation. So let's take a look at algebraic equations. So basically, an equation that involves algebraic expression is called algebraic equation. For example, I think we looked at some of them before. This x plus 1 is equal to 5. It's as simple as that. That's an algebraic equation. A trigonometric equation, as we looked at before, right? So we can say 1 plus tan squared theta is equal to secant squared theta is an algebraic trigonometric equation. Or you can say, for example, sine 2 theta is equal to 2 sine theta cosine theta is a trigonometric equation. So what's a function? We all know what a function is, right? Function is a mapping between two sets, right? So if we write it as f of x is equal to x squared, this basically you have a domain and you have a range. This is your domain and this is your range or codomain. And it takes an element x from the domain, and then it takes the function f, takes the value to the value from the domain to the values in range. So we say then this is the f, right? So we say that f of x, when you input this, when you feed this into your f, the output is your y. So f of x is equal to x squared is the function. Of course, every input, there are some definitions, there are some basic condition needs to be met, which is every input should have an output, and every input should have only one output. That is a function. And what is a derivative? We all know what the derivative is. You have learned them in calculus 1, calculus 2, and so on. So what is the derivative? So derivative is basically rate of change, right? If you have a function f of x, if you have a function which you write y is equal to f of x, the derivative we denote it by y prime, or we denote it by sometimes dy over dx, or we sometimes say if y is equal to f of x, we call that as the f prime of x is the derivative. And you all know how to, you're all experts in finding the derivative. So if I, for example, if I ask you what is the derivative of the function f of x is equal to x cubed, you would tell me the derivative is f prime of x equals 3x squared. We know that e to the x, the derivative is e to the x, and ln of x, the derivative is 1 over x. So you all know them very well. So, but we're going to use them. We're going to use them in the following sections. So now, what do you think of a differential equation, right? What do you think of a differential equation would be like, right? So the differential equation is basically an equation that involves derivatives, as simple as that. So the differential equation is a equation that involves derivatives. So for example, you can say this equation, f prime of x is equal to 1. That's an equation because you have an equal symbol in between, right? And that involves a derivative. This is a differential equation. Another example of that would be another example of that. And by the way, same thing can also be written something like that as well. Y prime is equal to 1, right? Or you can say, y prime is equal to 0, y double prime plus y prime plus y is equal to 1. That's the differential equation. Or you can say, y prime squared plus 5y equals sine x. These are all equations involving derivatives, and we call that as a differential equation. So let's try to take a look at some examples of a differential equation. I think what I have shown you are the differential equations. For example, you have a whole host of differential equations. So if you take a look, so any of them, right? This would be a differential equation. This is this is a differential equation. This is a differential equation. This is a differential equation. And as a matter of fact, this book has, right? This is a differential equation. A whole host of, I think, probably thousands and thousands of, differential equations. So this is a differential equation. This is a differential equation. This is a differential equation. So these are all examples of a differential equation. So let's take a look at, let's go back in here. So now we have whole host of differential equations. The question is, how do we classify a differential equation, right? How do we categorize the differential equation? There are a few ways we categorize the differential equation or classify the differential equation. Now, one of them is the order. One of them is the order. The other one is linearity. Then also we do something called homogeneity. So let's take a look at the order. So what is the order of the differential equation? So the order of the differential equation is basically the highest order of the derivative involved in that particular equation. So for example, if you take a look at this differential equation, which is a second derivative of y plus 5 times the first derivative of y times the cubed minus 4y is equal to e to the x. And by the way, there's another way to write it. If you don't want to write it using this notation, you can write it using this way, which is y prime plus 5y cubed minus 4y is equal to e to the x. That's perfectly all right as well. And this is called the Leibniz notation, right? And this is called the, I think, Newton's notation. You can use it either way. So now how do you find the second order? That's second derivative, right? This is the second derivative. Please make a note. How do we find the order? The order here is, so basically the highest derivative involved in this, even I think there's a 5y prime cubed. In this case, the highest order of the derivative is 2. So we call this the second order differential equation, right? So this would be a second order differential equations. If you take a look at the next one, which is x cubed y, the third derivative of y plus x times the first derivative of y minus 5 times y is equal to e to the x. And here, if you want to write it, using Newton's notation, this would be x cubed y triple prime plus x times y prime minus 5y is equal to e to the x. And this would be a third order differential equation. The reason because you have a third, the highest order. The highest order in this case would be a third order. And we can rewrite any differential equation in the normal form. And how do I rewrite the differential equation in the normal form? So the way that if you have a differential equation, I'll just say something like this. Xy prime plus 5y is equal to 0. That's differential equation. The reason it's a differential equation is because you have a y prime, right? You have a derivative involved in this one. So this is a differential equation, but I want to write it in the normal form. I want to write this in the normal form. So how do I do that? So basically, you take the highest derivative on one side, on your left-hand side, move everything else on the right-hand side. So something like this, right? Something like this. So you have the highest derivative in here, and then everything else on the other side. And we call such rewriting this differential equation is what we call the normal form of that differential equation. So if you take a look at the second order, you keep the second derivative on the left-hand side. You move everything, including the first derivative, on the right-hand side. So if you have an nth order differential equation, then you keep the nth derivative by itself, no coefficients, nothing multiplied, by itself, and you move everything else all the way up to the n minus 1th derivative, all the way up there, and this is called the normal form. And for some of you who you have not, I'm very positive you have seen this in your I'm very positive you have seen this in your calculus, but just in case you haven't seen it in the higher order derivatives, it is customary to write these things, namely, we write y prime as the first derivative, that's the second derivative, and this is the third derivative. This is the fourth derivative, and so on. But it becomes messy if I say 5, 6, and so on. So usually we write this as y in parenthesis 4. And then the fifth derivative would be y in parenthesis 5. If I'm asking what is the 2020th derivative, so you write it 2020. We don't want to put 2020 lines. That will be too much. So we write the derivative in this form. Again, this does not mean, let me make it one thing very clear. This does not mean this is y to the 4. This means the fourth derivative, d4 of y with respect to x. That's the fourth derivative, right? This is not y to the power raised to the power 4. These two are different, remember that. And that's what we mean by, in this case, y to the parenthesis n minus 1 is not the power. This is the n minus 1th derivative of the function y. So that's the normal form. So for example, in this particular example that I have shown here, how do I find the normal form? So we're going to rewrite this differential equation in the following way, and that would be y prime is equal to negative 5y over x, and that would be, and that's what we call a normal form of this differential equation. All right, I will stop it right here, and then I will come back and take a look at a few other terminologies and few other things with respect to differential equations in the next video.